Hey, classes, welcome back. Overall, this week we've been talking about pathogens, the stuff that can get inside you and make you sick. Notice, though, this has given us a good chance to jump off and talk a little bit more about evolution, the overarching theme for the whole class, the whole 9 months together. But when we're talking about pathogens, we're talking about viruses, we're talking about bacteria, we're talking about one-celled organisms, protists, and multi-celled organisms as well that can get inside of you and take up residence. And to make the list complete, we even talked about prions. We're not going to get to them in this class. They're a fascinating thing, though. They're a protein that changes the chirality, the way another protein looks, and it makes the proteins not function in your body anymore. Fairly recent discovery in the world of pathogens, which is fascinating. Notice we're not talking about radiation. Radiation, of course, can affect your DNA and change your DNA and cause things like cancer, but that is beyond the scope of pathogens because we're talking about biotic things that can change, that can activate your immune system. So let's jump on in. If you're looking at these notes that were up here the other day, this is a screenshot of pacificascience.org. Please make sure you check out that site. We are talking, those little things were supposed to be bugs. I drew them kind of fast. But when you're talking about the wide-scale use of pesticides, it gives us a good opportunity to talk a little bit about evolution and how it works, and also about when we're talking about using antibiotics against bacteria. The idea is because of mutations, because of small, and the most important word is random, because of small random changes in the DNA. If you use, for example, a broad-spectrum insecticide, or if you throw an antibiotic at a number of bacteria, it might wipe out almost all of them. But if you're talking about one or two surviving, those have a better chance of passing on their genes, which will then probably give some immunity to the next generation. We saw this with artificial selection. We saw this with natural selection. The artificial selection was one of my very, very favorite. And I'll link it down below. You can still catch this on YouTube. But Carl Sagan, a personal science hero of mine from years ago, does an excellent segment in his special Cosmos where he checks out the Hake crab. He talks about the Battle of Dano-Ura and how they found these crabs that were in the bay, and they would sometimes look a tiny, tiny bit like a face, and fishermen weren't all that anxious to eat a crab that had a carapace, a back, that had markings that looked even a tiny, tiny bit like a human face, and they would toss those back. It was almost kind of like a superstitious type of thing. But those crabs, if you think about it, are now able to reproduce. In many cases, those traits would be passed on. So in every case, they'd be passed on to the next generation, but in many cases, the next generation might look a little bit more, or might look a little bit like a human face, and that's evolution in action. You're selecting for a particular trait. And that was an example on the large scale. On the smaller scale, we were talking about insects, we were talking about bacteria, and the way that if you are trying to kill a large number of them, you can sometimes accidentally select for a trait that you're trying to get rid of. In the case of insects, for example, let me turn this off for just a second and click that one on. We're talking about mosquitoes, and that gave us a good jumping off point to talk about one of the most important scientists of our time, Rachel Carson. In 1962, she wrote the book Silent Spring, and it sounded the alarm about the widespread use of pesticides, insecticides, and the silent in Silent Spring has to do with the birds at her former college campus that she didn't hear anymore after an insecticide was sprayed in an attempt to control the beetle population, which was killing the trees on campus, but it had the unintended effect of, one, hurting the bird eggs. It caused birds to lay eggs that had thinner shells, and so the birds would not be able to reproduce. Now, in terms of pesticides, she was widely attacked by the chemical industry. It really is a travesty in terms of the way that she was verbally attacked. Although she did, one of her last public appearances, unfortunately she died of cancer in the 1960s, was in front of Congress, and she was talking about her book and how we have to be very cautious about the widespread use of pesticides. This does bring up a tricky social problem when you're talking about pesticides in general. Remember, we talked about malaria. Malaria is a disease that, now that one, in the case of malaria, you're talking about a protist, that spends part of its life cycle in the human liver. It can be deadly for kids. It is often deadly for kids, especially in sub-Saharan Africa. And one of the vectors for malaria, saw this the other day in class, is mosquitoes. And DDT was meant, among other things, to kill mosquitoes. Also, lice, for example, was widely used in World War II. But it's a cautionary tale about overusing pesticides, spraying them all over the place as opposed to very, very targeted areas. For example, DDT-treated nets versus spraying an entire field with pesticides, nets for sleeping, versus spraying an entire field with pesticides where you would kill virtually every insect in that field. And then also remember, getting back to the picture that I had up there from a couple of days ago, look at that with the bugs all drawn with slashes across them. Chances are, when you're talking about spraying an insecticide that's going to kill a broad spectrum of insects, well, there's going to be a couple that are going to have, just by chance, by mutation, a gene that might allow them to survive the spraying, and now they will be able to pass on their genes to the next generation. This is where we get the term superbug. We're also seeing this, we'll spend more time on this later, but we're also seeing this with the overuse, the overprescription, and the overuse of antibiotics. This is why doctors are very, very cautious about prescribing antibiotics if they're not really needed. Remember, antibiotics don't help you fight a cold. They help you fight a virus, which is one of our last jumping off points over here. Oh, by the way, the mosquito discussion also gets us into global climate change. Remember that as our climate warms, mosquitoes are able to live longer into the fall. They're able to come out earlier in the spring. And when you're talking about vectors of disease, mosquitoes are loving the idea that they've got a longer season to grow and to infect people. So it's one of the things, it's one of the tie-ins with our entire planet. We're talking about changing the climate by burning things like coal right here, big chunk of coal from my grandfather's backyard, actually. There's old slag heap back in West Virginia. When you're looking at burning fossil fuels that are adding carbon dioxide and methane to our atmospheres, you're talking about the warmest November ever recorded in human history that we just had, according to the latest data that's come in. So this is how it all ties together with human health and the health of our entire ecosystem. Over here we had an immune system graph that we just started on today. The clouds are things that we're going to get into later, but I'm going to point those out right now because when we're looking at this in particular, and I know Mr. Sewell's class does an excellent job with this, we're going to talk about human immunodeficiency virus, HIV, and one of the tricky things about HIV is that it attacks directly a person's immune system. We compared in class the innate immunity versus adaptive immunity. I tried to liken it, if you've ever heard the story of the Trojan wall and the Trojan horse. Of course, Troy was a big city under siege. You've got a giant wall around the city, and the innate immune system is a little bit like a walled city. The wall itself is supposed to protect the citizens, those inside the city. However, sometimes, the Trojan horse, if you know the story, sometimes things can get through the walls, and you're talking about, okay, this is where adaptive immunity comes into play. In other words, vaccines show your body what a virus or a pathogen is going to look like, and it gets your body ready to ramp up a response. This is why vaccines, when we spend more time next week, specifically on the coronavirus vaccine, we'll talk a little bit about how your body ramps up a response. So in other words, these two big blue clouds we have here, T cells and B cells, that's really going to be part of the focus of next week. But I wanted to give you a high level, the 30,000 foot view of the immune system. We talked a little bit about the mucus that helps surround things that you breathe in. And then, of course, you cough it out. That's part of your innate immunity. And finally, we talked a little bit about why smoking and vaping is such a bad thing when it comes to your innate immune system, because you've got these tiny, tiny hairs in your respiratory system, cilia, they're called. And as they catch the mucus that comes on down, as the mucus, gets caught in the cilia, the mucus is surrounding some potential pathogens that are trying to make it down deep into your lungs. the cilia do their little job. They're like little tiny hairs that are all pointing upwards. They're all pointing one direction, a little bit like a Venus flytrap that way, or one of those plants that have the tiny little hairs that are trying to direct the bugs down into a thing if it's a carnivorous plant, and the hairs don't let them walk backward. The cilia do the same thing for us. They let the mucus get caught, and then you cough, you expel whatever pathogen, whatever mucus-covered pathogen was trying to get into your lungs. If you smoke, if you vape, what it does, it destroys those cilia, and the mucus, again, possibly carrying something that can make you sick, can get down further into your lungs, cause infections. So this is why we have red ribbon weeks here at school. We talk so much about the importance of not smoking, not vaping, because it is one of the things that will help destroy your innate immune system. And of course, you want to keep that healthy. That's where we're going to leave it today. Please look for the notes online. And let me reach over here. Today's handout, which is, we'll get to tomorrow, the parts, the glands, and the organs that make up the human immune system. Have a great Wednesday, everyone, and see you online and in class. Bye-bye.